So this is the, we could label it as most hated problem on the exam, because this year's exam is quite difficult for students. It's one of the few problems in this range, from 15 to 25. There are two or three problems actually in the 15 to 20 range that actually is hard. And whenever they are hard, they immediately slow down students' pace and make them very nervous to finish the rest of the exam, right? So what is this problem? The problem is about placing numbers on a cube or a die, right? Place numbers 1, 2, 3, 4, 5, 6, 7, 8 on vertices of a cube. And then you look at each face, you add all the numbers on the 4 vertices, and you get a sum. And somehow we want this sum for each face is the same. And we want to know how many such arrangements are there. And the rotations are considered the same. If you can rotate the 2 dice, you can match the arrangement, then they are the same arrangement, right? So this problem is difficult. It's actually, I think there are a few layers. The first question is we ask there, question number 1, what is this sum? What is this fixed sum, right? Without that, you cannot go anywhere, right? And then even with this sum in mind, can you find one arrangement, right? And then you can think about how many ways I can relabel them and they are different, right? So we give you another similar problem, but an easier version. How many ways to arrange numbers 1, 2, 3, 4, 5, 6 on a die? And they could become a different die, right? And the rotations can be considered the same. And think about those 3 problems, and I think those 3 questions, and they will help you to solve this problem. So we answer our first question, what is this sum? Well, this is a very typical calculating 2 ways problem, right? You look at the number A, let's say A, how many times it contributes to a sum? It contributes in 1, 2, and 3, because each vertex is what? Lies on 3 faces. So that means if I add all the sums, 6 faces, then each number should appear 3 times. So that means this sum should equal to 3 right? So that means and that's 18. So we know the sum must be 18. Can we find one arrangement? Well, even though all these numbers are equivalent to each other when they play the role of on these dice, right? But to me, if I really want to find the arrangement, I want to start with either the high number or the what? Or the low number, because they give me limited choice, right? So assume this number is 1. So let's see the 3 groups that are going to go with it. So let's see, this is A, B, and C, and the 2 further away 3 points are Z, Y, and X. Do you know why I label them this way? I don't know. It feels to me it's like I want 3 neighbors first, and then 3 what? √2 distance away, right? Okay. So how many ways I can make? So that means what? If we go with 18, I should have what? A plus Z plus B is equal to 17. And B plus X plus C should equal to what? 17. And then A plus Y plus C is equal to 17, right? So there are very limited choice for that. How many times I can get 3 numbers add up to 17 using what? 2 through 8. So the average is about what? 6, very close to 6. So I have to use big numbers, right? So I could have what? 1, go with what? 8, 7, and 5. That's one of them, right? Because I cannot use 866, right?
872.
Sorry, 872. That works. Sorry. And then 8 what? 6, 3. And 8 what? 5, 4. Right? And then I also can use what? For example, 7. If I use 7, what do I get?
You're only
6,
7, 6, 4.
and 4. That's it. I cannot have my largest number become 6 because then my average is more than what? It will be more than that, right?
If your biggest number is 6, then the best you can do is 6, 5, 4.
Yeah, that's the maximum is 15, right? So I only have what? This what? 3 groups, right? So that means 3 of those has to be what? Coming from here, right? So what's the conclusion now? The conclusion is actually I cannot take all these 3. Because among these 6 numbers, each of them can only at most appear what? Twice. You can have the A's, they appear twice, the B's appear twice, and the C's appear twice, right? But the X, Y, Z only appear what? Once. I cannot have what? All 3 A's. So that means I must have what? This guy. So that is very good. So that means
So you know
start
one
from
face.
there. I know one face now. I still do not know if they are all equivalent, right? So suppose I have them 7, 6, and 4, right? What are other 2? Other 2 both have what? 8. I look at the other 2 faces. Which one allow me to have one number that appear twice? C, right? So I must have 8. And then
You just fill it.
then everything is very much filled because this tells me if I have 1, 8, and 4, I must have what? 5. So this is fixed. And then what? The other one is with 7. So 2 is what? Fixed. Right? If I have 6 here, then what happens? Then I can take what? 3.
Well, and then the one in the very back, right?
Right? So the one on the very back is the one.
So, and that one's always, we know for sure it's going to be safe because that's how we chose our sums to be 18.
Right. This is, which number is that?
That's 3.
3.
For this. We know we can satisfy all 3 of the faces at the same time.
So now we talk about how many ways you can arrange them, right? How many ways we can arrange these 6 numbers? It's better to think about them this way. I have 2 dice. If I really want to compare if they are the same or not, I better what? Match certain positions. If I have 2 dice, how do I know they are the same? For example, over here, I both put 1 on the top, right? So if I know how many ways I can turn the dice, it's very simple. I put 1 on the top, right? And then the next thing I can say is, if I have a 2 on the side or not, it's actually very hard to see because I do not know. I need to turn more, right? So the easiest way for me to compare now, if 2 dice both have 1 up, is actually see the what? See the bottom. If the bottoms are different, they are clearly different. right? So this tells me actually how do I count how many what? Arrangements. So the bottom has what? 5 choices, right? Yeah. Right? And then when I have my top and the bottoms are fixed, I can turn this around, right? So I have 4 numbers left. I have A, B, C, D basically. But because I can turn them around, where do I place this first number doesn't really matter,
So let's put it in the front.
right? So I can put this A always what? Up over here. And then my dice is what? Is fixed, right? Physically, you cannot move it anymore. You have the top, you have the bottom, and then you have a front face. And then how many ways we can arrange those 3 numbers? 6 ways, right? 3 factorial. So this is 5 times 1, 3 factorial. So 3, right? So based on this, how do we do this one? What do we think?
So we can fix the 1 first.
We can fix the 1 first. It doesn't matter. It can be any corner,
Yeah.
right? And then what?
And then we fix the order on the top face that we always know exists, 7, 6, 4.
7, 6, 4, right? How many are there? There are 6 ways, right? Because 7, 6, 4, you have what? 3 factorial ways to arrange them, right? And then whenever they are fixed,
I think your die is decided or your cube is decided.
your cube is already decided,
Because of that 8.
right?
Because that 8 I think is important.
That 8 is very important because if you know that 8, you know all the leftover numbers that needs to be on that face, and then you're done, right? So the answer is what?
So it comes down to arranging the 7, 6, and 4.
Yeah.
Which there are 3 factorial ways.
Yes. It's all about how to arrange these 3 numbers, right?